Hi again. We are going to continue this problem where we're trying to find the center of mass of this thing right here. So far, we did the work to find the mass. It was 8 over 15. That would be the mass of this thing. And then we quickly argued that x bar was 0 because of symmetry, because the left and the right halves are the same here. So the center of mass, x-wise, has to be on the y-axis there. So now what I'm going to do is find y bar, which is going to be 1 over m times the double integral of y times density dA. So 1 over m double integral over r of y times density dA. Now, my bounds are going to be the same as before. Oh, I guess the mass, when I flip 8/15, I get 15 over 8. And then I'm going to do the integral from -1 to 1, and then the integral from 0 to 1 minus x squared. Same bounds that I had up here initially when we were doing the y center, or the actual mass. And then I've got y is this right here, and then remember the density itself was also y. So we're going to have a y squared when we multiply those two. And same order again, dx, sorry, not dx first, dy, then dx. Okay, so let's go ahead and calculate this integral. This one, you could make an argument like I made earlier for reducing this down from 0 to 1, but it might not be so obvious as to why we can do that in this one, because it's hard to visualize that above, right? We could, but I'm going to go ahead and do it from -1 to 1. And you'll see that it works out as if I did a 0 here and then put a 2 out front. So first thing we need to do is integrate with respect to y. So we get 15 over 8 integral -1 to 1. When I integrate that, I get 1/3 y cubed, evaluated from 0 to 1 minus x squared, and then I'm left with my dx. This 1/3 is actually kind of nice because it divides into the 15 to give me a 5. So I have 5 over 8 integral -1 to 1 of same thing I'm going to get that I had up here, where I subtract a 0 piece out because I'm going to plug in this there. So I'm just going to write the 1 minus x squared cubed dx. Now I'm going to use a trick that I think you should be familiar with, but you may not be familiar with it. I'm going to use Pascal's triangle to expand this polynomial. It's cubed, so I'm going to go down to the row that has, it's the row with 4 terms in it. It's the 4th row, or unless you call this the 0th row. But anyway, hopefully you know how to build Pascal's triangle. 1, 1, 1, and then I put a 1 here. I add this number and this number, and I get a 2. And then I take this number, or I take a 1, and I put it right there. Notice 1, 2, 1 matches the coefficients here, 1, 2, and 1. And that came from squaring. So the same thing works with the next row. 1, 3, 3, 1. Those will match the coefficients of this thing cubed. So I get 5 over 8 integral -1 to 1. Oh, I should point out, if I had an x there, I could do some u sub, and this would be a lot easier. But I don't, so we need to FOIL this out, or expand this polynomial. So what I'm going to get is 1. That is this coefficient. Now I'm going to get -3. That's this coefficient. And then this thing is going to go up to a power of, well, what I have here, which is x squared. And then I'm going to get plus, it alternates because of this being negative. I'm going to get a 3, and then I'm going to get this right here squared. So that gives me x to the 4th. Because this is, you could think about it as that squared is what makes this positive. And then the last term is going to be minus coefficient of 1, and this thing cubed, so I get minus x cubed. If you're like, say what? we can practice some of this and talk about why this works in class. But for now, if you cube this, you get this. An alternative way to get that would be to take what we had previously, this, and multiply it by 1 minus x squared, because that would be 3 of them multiplied. You would get this same thing if you did your work right. So dx. Okay, so now we've got 5 over 8. Now, I've got something that I can do. Why did I say cubed? Oh, no. 6. I cubed the squared. My bad. You would get this if you did it right. Sorry. Okay, so now I'm going to integrate this thing because I got a bunch of stuff here that I can do power rule with. So I will bracket it. I'm going to get an x. That's the first term integrated. Minus x cubed. I'm going to double check in my head that that worked out correctly. And it did. It did. And then I get here and I'm baited into writing, I don't know what, but it's plus 3. When I power rule that, I get a 5 x to the 5th minus 1/7 x to the 7th. And that needs to get evaluated from -1 to 1. So from here, I've got 5/8 times, I'm going to go one term minus another term. All right, so let's see what we have here. When I plug in 1 to this, I get 1 minus 1 plus 3/5, and then minus 1/7. When I plug in -1 to this thing, notice all of these are odd powers. So what's that -1 going to do? It's just going to change the sign out front of all of these things. So I'm going to get a -1. I'm going to get a +1. I'm going to get a minus 3 over 5. And then I'm going to get a plus 1 over 7. What I want you to see is that, well, one, these cancel, and that's nice and all, but I want to talk about the whole changing that to a 0 and then putting a 2 right there. Notice if I had changed it to a 0, this term wouldn't be there, and I would put a 2 out front here. Essentially, and that 2 could be distributed into this part. You should see that this piece is exactly the same as this piece if I were to apply that negative into all these guys. So what I said earlier would work, and this should show it to you a little bit, but if you don't catch that, you just have to evaluate a couple more things, and you don't get to take advantage of the zeros. So 5 over 8, all right, so I've got those guys cancel, and those cancel. I've got a 3/5 and then another 3/5, so that gives me 6 over 5. And then I've got a 1/7 and a -1/7 and then another -1/7. So minus 2 over 7. And this common denominator would be 35. So 5 over 8 times 35. And then the 6 needs to get multiplied by 7. Gives me a 42. The 2 needs to get multiplied by 5. It's negative, so it gives me 10. So a couple things to cancel here. The 5 goes into the 35 and gives me a 7. So I get 1/8 and then over 7. And then 42 minus 10, that's kind of convenient. That gives me 32. So I can divide the 8 into the 32 and I get 4 over 7. And that is my y bar. So we'll circle that. And, I've got my mass here, my x bar is here, my y bar is here. What you should really say at the end is that, center of mass is x bar, comma y bar equal 0, comma 4/7. So, comments. 1, I hope you're okay with all the math that I used to get there. I hope that this demonstrates for you one thing that we can do with double integrals. I hope that you see what I mean by this being a flat plate with a density in terms of grams per centimeter squared, or mass per length squared, whatever mass and length you're working in. So I hope you see how that works. I hope you see some of these little tricks that we can use in terms of Pascal's triangle and doing this double thing and getting the zero. And I also hope that you can say to yourself, well, if I had a three-dimensional object with a mass at with a density at different spots, if I could somehow come up with the equation of all those different pieces, then I could do this same type of calculation and find an x bar, comma y bar, comma z bar if I knew how to do a triple integral. And that is something that we will get to later. That's all I got for this. I will see you soon. Thank you.